Okay, we are back for another installment of connecting your old school math to your kids' new and improved math. And today we're going to take a look at partial sums and partial differences. Now, I will tell you that this video is probably going to be less about connecting what you learned in school to what your kid is learning now and more about making you understand what they're doing, okay? Because I don't remember us doing anything quite like this whenever we were in school, but it's mathematically sound. And as long as you understand what they're doing, then you can help them with their homework. All right, so partial sums and differences. I want us to start by looking at the word partial. The root of the word partial is part. Part means a piece of something, which combined with other pieces make up the whole. Some, but not all of something. I want us to focus on the first part of that definition before the semicolon. A piece of something, when combined with other pieces, make up the whole. Students are going to continue to use the concept of combining parts to make the whole answer as they learn more mathematic operations. So in other words, they're going to use this idea when they multiply and when they divide. So this tracks all the way up through 4th and 5th grade. So we really want them to understand finding part of a sum or part of a difference and then putting it back together again. All right, so how are we going to do that? We're going to use expanded form. Expanded form is when you break numbers into parts based on place value. Now, partial sums and differences, this is a strategy that you're going to use before the standard algorithm. So if you've already watched the video on carrying and borrowing and how we don't do that anymore, then this strategy would be a strategy that a student would learn before the standard algorithm. So we're talking 1st and 2nd grade with this. So we've got 147 and we're going to expand it into place value. 269, expand it. All right, and then now let's put these expanded parts together. All right, so 100 plus 200 is 300. 40 plus 60 is 100. 7 plus 9 is 16. So now I have these parts that I can put together to find the whole answer. So 416 is the sum. That is the answer to this problem over here. But these parts, those are your partial sums. And so what you're doing in this strategy is you're finding the partial sums and then you put them together. Okay, as I said, this would be a strategy that students would learn before that standard algorithm, before they know to regroup this 16 into a 6 and a 10, into 6 ones and 1 10. All right, let's look at another one, 56 plus 27. So what we're going to do is we're going to break it apart by place values. So we've got our tens and our ones. And so now what we're going to do is we're going to put those parts together. Okay, so sometimes every teacher and every school and every program is going to have a little bit different way of recording partial sums and partial differences. But if you know what's going on, you're going to be able to help your kid. The students that I work with will often see the parentheses used to group the place value. So I often put those in and tell them, this is showing that these all go together and this is showing that these go together. All right, so that gives us 70 plus 13. Kids can add that. That's 83. All right, let's look at one with hundreds. All right, so we're going to put our hundreds together, our tens together, and our ones together. And as I said, my students often see it with parentheses, so I like to show them that. I consider this step right here, I consider that a teaching tool. I'm not expecting students to write this down. I'm hopeful that they can look and they can say, all right, 500 plus 200, that's 700. 10 plus 30, that's 40, so 740. And then 7 plus 4, that's 11. So that's going to be 700 plus 40 plus 11, 751. Okay, and so this line right here, I use that when I'm working that with my students, but this is really me explaining the process, whenever they're doing it, I want them just to write this part down. And y'all, they'll get to the point that they don't even have to write that down and they can just do it in their heads. All right. So let's look at partial differences. 894 minus 261. Now you may have noticed that for the most part, I've not been stacking the numbers on each other like you were taught to do, okay? You probably would have written this with the 261 underneath. But I'm intentionally not stacking them up because I want the students to focus on the entire number and the value of the digit, not whether they are lining things up correctly, okay? If you've ever seen a second or third grader's handwriting, some kids look like a typewriter, but a lot of them, it's just a big old hot mess. And for those students, the emphasis becomes less about the math and more about neatness. And we really want it to be about the math and the value of the place. So what do you do, mom, dad, if you're a stacker and you just can't let it go? All right. So be sure, if that's your situation, make sure you're emphasizing the place value, because ultimately that's why we stack the numbers up anyway, because we're wanting to get our places in line. And so that's why we do it. So anyway, sidebar, partial sums and differences. All right, so we're going to find the difference of 800 and 200, the difference of 90 and 60, and the difference of 4 and 1. And gasp, we're going to put them back together. Now, this is the part where kids get a little bit confused with partial differences, because there's a plus sign and this is a minus problem. And that's where we go back to that definition and we talk about how part means a piece of something that we put back together to make the whole. So we can find these part answers and then we put them back together to get the whole answer. All right, so 600 plus 30 plus 3, that's 633. These are our partial differences, and there's our difference. Okay? All right, another partial difference. 61 minus 24. Let's think about how we would work this using the partial difference strategy. We're going to break it apart by place value. 60 minus 20, that's 40. And then 1 minus 4, and this is why partial difference strategy is a lot less prevalent than partial sums, because you do get into negatives. And we often say with kids, 1 minus 4, oh, you can't do that. So, but you can. 1 minus 4 is -3. And it's okay to have those conversations with younger students. They can understand the concept of owing someone something, okay? If they've only got $1, but they need to pay me $4, they're going to give me their dollar today, and tomorrow, how many dollars are you going to bring me? 3, because you owe me $3. All right, and so then we're going to add those back together. So we would take 40 plus our -3, 40 plus owing 3, and a lot of times in this type of situation, we visualize a number line. I don't have a video on number lines just yet, but there's going to be one coming, so watch for that. All right, when we owe something, we're going to move backwards on the number line. So 40, back up 3, and that's going to put us at 37. So 61 minus 24 is 37. And we did that using partial differences as opposed to that standard algorithm. All right, let's look at one with hundreds. All right, 700 minus 200 is 500. 30 minus 50, you can do that. You're going to owe 20. And then 4 minus 3, that's 1. All right, and so we can group those place values together. And y'all, just like with the partial sums, and I said, I really consider this line a teaching tool. I'm not really expecting kids to write this part down. Same with the partial differences. I hope that they could skip to 500 plus owing 20 plus 1. All right, and so if we do that, 500 owe 20, well, 500 back up 2 tens, that would be 480, plus that 1, 481. And so that is the partial difference method of solving that problem. Now, I'll be honest with you, partial differences, a lot less prevalent than partial sums because of that kind of hesitancy to talk about negative numbers in elementary school, but it exists, and so I wanted to show you that, and I hope this helps you understand, if your student has been using partial sums, helps you maybe understand how to explain it a little bit to your student. As I said, partial differences is not as prevalent, but it works every time. But I do have some strategies, some alternatives to partial differences that we'll delve into in some future videos. All right, guys, I hope this was helpful in helping you understand your kids' math.